topic for today is the determinant of a square matrix. Wouldn't hurt to check. Okay. All right. So remember this slide from a while back when we talked about how to find the inverse of a 2 by 2 matrix? Okay, so we're kind of out of sequence a little bit. I think if I have the time this next fall, I'm going to rearrange things so that things flow better. Okay, because we talked about how to find the determinant of a matrix, and then we took 1 over that determinant times the mixed up matrix to find the inverse of a 2 by 2. Okay, so there's no reason to write this down. We know how to do this. Okay, in fact, I could see on your quiz, I haven't finished grading your quizzes, but it looks like you did really well with that. So what we want you to do is find the determinant of 3 little 2 by 2 matrices really quickly. See how fast it is to do that, or how easy it is to do that. And we're going to do some of that on your homework today, but then we're going to build on that and actually find determinants of 3 by 3 and 4 by 4 matrices. So first of all, you can only find a determinant of a square matrix. And we find it by taking, if our matrix is in the order of A, B, C, D, A times D minus C times B, or B times C, depending on which way you write it. So, Davina, what would we get on our downward diagonal for matrix A? And what would we get on the upper? Good, because it would be a -3, but we always want to change that sign so we can make it an addition problem. Okay, it's usually 6 of one, half a dozen of the other. If you can remember that you're going to take the downward diagonal minus the upper, you're fine. But I'll show you a trick for the 3 by 3s that's going to be beneficial just to change the sign on the way up. Does that make sense? So when we add 10 and 3, we get 13, and we're good. Okay, that is the determinant. Okay, I'm not going to take you to the next step where we find the inverse of that matrix. We're just done with the determinant. So far, so good? Okay. All right, Ruthie, what are we going to get on our downward diagonal on matrix B? And upward? So all together we get? Excellent. Okay. Yes. You don't have to put the 1 over it, and you don't have to mix up the matrix. Okay. So we don't have to find the inverse matrix here. All we're finding is the determinant. Okay. And Abby, what are we going to get when we do our downward diagonal here? An upward diagonal. And so our result is, okay, make sense? Which of these 3 matrices would not have an inverse? C, okay, because we can't divide by 0, right? And it makes sense if you think about it. If this was the coefficient matrix for some equation, and we had 3x plus 6y equals some number, and 2x plus 4y equals some number, what kind of equations, or what would be the relationship between those lines? They'd have the same slope, right? They'd be equal. They're basically multiples of each other, kind of. So since they would have the same slope, we took the 3 to the other side, divided by 3, right? Or I'm sorry, divided by 6, we'd have 1/2 for our slope. Take the 2x to the other side, negative 1/2 our slope up here. We'll have a negative 1/2 for our slope here. So it makes sense that these are inconsistent, right? They're not going to have one place where they cross. They're parallel lines. So that's why there is no inverse. Okay. All right. Questions so far? Okay. So now on to a 3 by 3. To understand how to find the determinant of a 3 by 3 matrix, we have to understand what minors are and what cofactors are. Okay, 2 new terms. So if we have a square matrix, then the minor of an entry in that matrix, A sub ij, is the determinant of the matrix obtained by deleting the ith row and the jth column. Okay, we know how to find a determinant of a 2 by 2, right? Okay, so to find the determinant of a 3 by 3, we're going to have to get rid of a row and a column. So we're back down to a 2 by 2. Okay, So you have to understand what a minor is and what a cofactor is. It's going to seem strange until we put numbers to it, and then it'll make sense. Okay? So the cofactor of that ij element of A is equal to -1 to the I plus j power times the minor of that ij element. Seems like hieroglyphics at the moment, doesn't it? Okay. So first of all, we're going to understand what a minor is. Okay. And then we have to figure out what we have to do to make it a cofactor. So we can call it cofactor expansion. So first of all, let's look at this cofactor thing. The only thing different, we're going to worry about the minor in just a moment. The only thing that's happening with the cofactor is we're looking at whether we're changing the sign or not. So far, so good? Okay. So if I'm in the first row, first column, okay, if this is my first row, first column element, 1 plus 1 is 2. 2 is an even power, right? So -1 to an even power is a positive 1, a positive, okay? So are we changing the sign of the minor when we're in the first row, first column? No, we keep it whatever that minor is. And all that minor is a determinant, a 2 by 2 determinant that we've evaluated, or a matrix, the determinant of a 2 by 2 matrix, okay? So we're going to have a number here, and if it's in the first row, first column, we don't have to worry about changing the sign, okay? If we're in the first row, second column, 1 plus 2 is 3, right? So -1 to an odd power, like 3, we're going to get -1, okay? So whatever we get from our for our minor, that whatever determinant we get there, we would have to change the sign. If it's already positive, it's going to be negative. If it was negative, it will be positive. So far, so good on the cofactor part. Okay? First row, third column, 1 plus 3 is, so we've got -1 to an even power again, right? So are we changing the sign of our minor? No. Second row, first column, odd power, right? So are we changing the sign? Yes. Okay, so far so good? Okay, that's the cofactor part. Now let's look at the minor part. Okay, so here we go. Let's pick on a row. Doesn't matter which row we're going to pick on, okay, or a column. I decided let's just do column 2. Kicks and giggles, we're going to use column 2. And I want you to help me find the minors and the cofactors of column 2 for this matrix A. It's a 3 by 3 matrix. The first row is 3, -2, 4. The second row is 3, 2, 1. And the third row is -1, 3, 6. Okay? So we've just randomly chosen column 2 to work with. Okay? So what is the element in row 1, column 2? What's the value there? 2. -2. Okay, so that's -2. Okay? So I want you to help me find the minor of row 1, column 2. Well, that's a determinant. The determinant mark is, or the symbol for a determinant, loses the little brackets, and they become like absolute value signs. Okay? Well, we want to find the minor of a particular row, or of a particular element. All we do is we say, hey, we're going to eliminate that row and that column and tell me what's left. Okay? So if we are in first row, second column, we're eliminating this row, this column. So what is left? All right. And we know how to evaluate that determinant, don't we? Okay. So what is that determinant's value? 18 on the major diagonal and -1 on the minor, but we change the sign and we get 19. All right, so the minor for row 1, column 2's element is 19. Okay? To find the cofactor for row 1, column 2, we need to figure out whether we have to change the sign or not. We're taking -1 to the 1 plus 2 power times the minor, times the 19 we just found. Okay, 1 plus 2 is, that's I and j. Okay, I is your row, j is your column. So 3, -1 to the 3rd power is, so we're changing the sign of 19, aren't we? We're going to have a -19. Okay, this is just the element number. Okay, so when we have a matrix A, we have a 1, 1, a 1, 2, a 1, 3, and so forth. Okay, makes sense? Okay, so I'm just designating this one just so you know this is his value in that element's value. This is the value for its minor, and this is going to be the value for its cofactor. Yes, sir. Okay, the I is the row number, and the J is the column number. Okay, so far so good? Okay, so I just took my row number plus my column number to see what my power is going to be for the -1. And then if that is an odd power, it will make it a negative. And if it's an even power, it'll be positive. And I take that number times my minor for that particular element. Okay, so far so good? All right, try it for a 2, 2. A 2, 2 has a value of 2, but I want you to find the minor for row 2, column 2. And then I want you to find the cofactor for row 2, column 2. Everybody get 22 for the minor. Okay? All right, now we have to figure out whether we are changing the sign or not. -1 to the row plus j to the 4th is positive, right? We take that times 22, and we get 22. So the cofactor of the second row, second column is 22. Make sense? Okay, let's find the minor and cofactor for row 3, column 2. That one's value, that element is 3. We want to figure out what its minor and its cofactor are. Get negative 9 for the minor. And a positive 9 for the cofactor. Yes, all right. Questions on this one? It was a negative 9, right? So we take our change, okay? Change the sign of your upper diagonal, okay, so you don't forget to subtract. Everybody get positive 9? All right. Questions on the minors and the cofactors? Okay, so now that we understand what minors and cofactors are, now we get to use them to help us find the determinant of a 3 by 3. Okay, so here's how it works. We're going to expand by cofactors, or expansion by minors is also how I've heard it called in other books. Okay, once a convenient, or first of all, you want to choose a convenient row. Okay, preferably, or column, preferably one with zeros in it. Okay, and I'll explain why in just a moment. And then you expand the row or column by the cofactors to find the determinant. So if we're trying to find the determinant of this matrix A, which has 3, negative 2, 4 for its top row, 3, 2, 1 for its second row, and negative 1, 3, 6 for its third row, we can pick any row or any column. It doesn't matter. We're all going to get the same determinant. Okay? If we do our math correctly, don't make a mistake, we'll all get the same number for our determinant. Okay? I just happen to choose row 1 because there are no zeros. There are no convenient numbers. So far, so good? All right, so the determinant of A, if I'm expanding by row 1, is 3 times the cofactor of row 1, column 1, plus a negative 2 times the cofactor of row 1, column 2, plus 4 times the cofactor of row 1, column 3. Where are the 3, negative 2, and 4 coming from? Yeah, those are those elements of those particular places, right? So we take this number times its cofactor, which means we found the minor, the determinant of the eliminated row and column, and then check to see whether we had to change the sign or not, right? Negative 2 times the minor for this one with the cofactor change, right? Whether we're changing the sign or not. And then 4 times the minor of row 1, column 3 with the sign change if necessary. Make sense? Okay. So someone else may choose to do column 2 or row 3 or column 1. And you'll all get the same number for your determinant. Okay? So let's do this. The determinant of A will be 3 times the cofactor of row 1, column 1. So the minor of 1, 1 is going to be eliminate row 1 and column 1. And what's in our determinant? Okay, so we evaluate that, and we get 12 and 3 negative, right? 12 minus 3 is 9. All right, cofactor-wise, do we have what is our power going to be? 2. So a positive 1 times a 9 is positive 9. So we're taking 3 times 9 so far. And we're going to add that to, do another color here, negative 2 times the cofactor of row 1, column 2. Well, to find the cofactor of row 1, column 2, I've got to find the minor of row 1, column 2. What's the minor of row 1, column 2? Absolutely. Now evaluate the determinant. 3 times 6 is negative 1 times 1. Change the sign. 19. So the minor is 19. What about the cofactor of row 1, column 2? Negative 1 to the third times 19 will be negative 19. Okay, third color here. Now we've got to take 4 times the cofactor for row 1, column 3. Okay, so what's the minor for row 1, column 3? What determinant will help us get that? What should the values be? Okay, let's evaluate that determinant. 3 times 3, negative 1 times 2. So change the sign and add. So the minor is 11. What's the cofactor going to be? 11. Okay, so far so good? All right, so we take the element times its cofactor, and we're going to get 27 plus 38, right? Plus 44. 27 plus 38 plus 44 is 109. Is that correct? Someone check our math. Okay, so it doesn't matter if we did this by expanded by row 1 or column 3 or row 2. We're going to all get the same number. Make sense? That's the determinant of a 3 by 3. That's just the determinant. Okay? So far so good? No, I want to show you another method. Okay? And then I'll explain why they give you this method when it comes to a 4 by 4. Okay? Here's another method of finding a determinant of a 3 by 3. Big process, isn't it? Okay? So here's our new 3 by 3. This is matrix B. Different methods, so we're not going to actually choose. But yes, if I were choosing, I would choose row 2 or column 3. Why? And 0 times its leftover determinant is going to be 0, right? So you've eliminated a third of your work. Does that make sense? Okay? So that's why we want to choose an appropriate row if possible. Okay? Or an appropriate column. Okay? All right, so in this case, though, I want to show you the diagonal method. And our book doesn't show it to you because back when I was in your seat, we only did matrix determinants of 2 by 2s and 3 by 3s. And of course, you guys are highly evolved and much better than we are and so forth. You've learned so much more because of the technology and everything else. It's faster. So now you get to do college level work and do a 4 by 4 instead. Okay? So here's how it works. So we're going to rewrite our first 2 columns. Only the first 2 columns. Okay? So we'll copy them down right beside it. You can decide whether to include the 5 or not because it's really not absolutely necessary. It won't be used. And save a little bit of pencil lead. Okay? All right, now, the reason I keep telling you to change the sign of the upper diagonal is so that you don't have to think, okay, I'm subtracting here, I'm adding here, I'm subtracting here, I'm adding here. Because watch what happens. On your downward diagonals, we're going to multiply and keep the sign the same. So 3 times 5 and times 1 is 15, right? Okay. 4 times 0 times negative 1. 4 times 0 is 0 times negative 1 is 0. Okay? One more time. Negative 2 times 3 times 4, negative 24. Okay? So this is called a diagonal method. Okay? Rather than have to make all the cofactors and minors for a particular row or column, you can simply rewrite the first two columns over, and then you say, I'm going to find the diagonals. I'm going to multiply the diagonals and add them all up when it's all said and done. Because watch what happens if I do this in this way. So here's my first diagonal, right? Second diagonal, third diagonal. Okay, all three got hit, right? Or most of those got hit. 3 of those got hit. Watch what happens when we go the opposite way. Negative 1 times 5 times negative 2. Positive 10, right? Okay. It was a 10, but we have to change the sign because we're going to remember to change the sign on the upward diagonals each time. Okay? Watch what happens when we do 4 times 0 times 3. 0. And 1 times 3 times 4. Times, multiply. 12, and change the sign. Okay? Did we ever hit this number if it was there? No. So you don't have to have it there. You can. Okay? Don't confuse yourself by not putting it there. But it doesn't need to be there. So basically, exactly. Some of the, well, this one doesn't get used either direction, does it? Okay. Yeah. So you just basically just keep the matrix the same as it is, right? Recopy your two columns. If you include that or don't, it doesn't matter because you're not going to use it to multiply. Okay. So far, so good? Okay. Now, we changed the sign on both the 10 and the 12 because we're going upward. Okay. In our method with the 2 by 2, we said AD minus BC, right? Okay. That was only one subtraction problem to keep track of. Now we've got potentially 3 if there aren't any zeros, right? So rather than have to worry about whether I'm adding or subtracting and so forth, it's just easier to multiply. When you get to the top, change the sign. Okay? If it was a positive 2, it would be a negative 2. If it was a negative 2, it would be a positive 2. We just change the sign on the upward. It's kind of like our cofactors, right? So half of them are going, portion of them are going to change the signs. Okay? So now, final answer here. What is negative 10 plus negative 12 plus 15 plus negative 24? So we'll have a negative 22 minus 24 and then plus 15. Is it negative 33 altogether? Someone check our math. Negative 36, negative 46, 46 minus 31. Negative 31. So which is easier, diagonal method or definitely diagonal, right? Okay. So far so good? Okay, questions on this one? There's more, okay? Because now we want to know how to find a 4 by 4 matrix. Absolutely. Yep. Until this next slide. Okay? Okay, so here's the next slide. I want you to practice this. It's not going to be a test question. It will be a bonus question on your tests for extra credit. Okay, but I want you to practice it. Okay? Stretches your repertoire, makes you a better mathematician. We can use a diagonal method, but we have to understand expansion by minors, don't we, in order to be able to use the diagonal method with this one. Okay? So, first of all, write your matrix down. It's now a 4 by 4. Then be strategic. Decide which row or column is the most convenient one to use. Ethan's liking row 2. Everybody agree? Column 4 is pretty darn good, but not quite as good as column 4 is really good, but not nearly as good as row 3, right? Okay. So we're going to work smarter, not harder, right? Okay. So now that we know how to find the determinant of a 3 by 3, we're going to find the determinant of a 3 by 3, but we're going to have to expand by minors, right, or expansion by cofactors with this 4 by 4. So we're choosing a row to be able to work with, right? And that is this row 2. Because we know that 0 times any 3 by 3 matrix is going to be 0. And this 0 times a matrix and this 0 times a matrix are going to get us zeros. So the only one we have to worry about is that -1, which is the value of a, what? 2, 2, 3. So A23 is the guy we're working with. It has a value of a -1. Okay, so to find the determinant of matrix A, we've got to take A23 times its cofactor. Plus 0, plus 0, plus 0. And we're done. Make sense? Okay. So we're going to take that -1 times whatever the cofactor is. But we have to find the minor first. Okay. How do we find the minor for row 2, column 3? Well, we eliminate row 2 and column 3, and what's left? 6, 4, 0, 3, 1, 7, right? And -5, 4, 3. Okay? So far, so good? Rewrite the first 2 columns. Decide whether you want to include the pencil lead or use the pencil lead for that number 1 or not. All right, what'd you get in your downward diagonals? Very good. Everybody get 18, -140, and 0? Okay. Now we do our upward diagonals, and we have to remember to change the sign, right? But you get 0, -108, and -36. Oh, nope. Because when we're doing our upward diagonal, we're changing our signs, right? That way we're only dealing with addition at the end. Oh, 168. Thank you. Yes, 42. 42. Yes, 168. My apologies. We get -326 altogether. Okay. So the minor is -326. (42 times 4, 160, 168). Yep. So far, so good? Okay. Now we have to find the cofactor of row 2, column 3. So the cofactor of row 2, column 3 is going to be negative 1 to the 5th power times that negative 326. Odd power means negative, right? Negative times negative is positive. So the cofactor is a positive 326. So we plop that into this spot, and our overall determinants answer for this 4 by 4 matrix, negative 326. Because the negative 1 came from the elements, the row. Yep. The value of that element. Yep. Because of this negative 1 right here. If it had been a 2 or a 5, we would have, yep, whatever number that happens to be. Good question. You're going to see it tomorrow when we do work with, or Monday when we work with Cramer's rule. And they'll probably have some real world examples of when we would use determinants to solve systems. Absolutely. This is the piece of the next puzzle. We have to know how to do determinants for 2 by 2s, 3 by 3s, but potentially 4 by 4s. Okay? Just a skill. All right, we feeling okay? All right. So if, of course, it hadn't been a row that had all but one 0, then you would have had to do 2 of them, for example, and figure out what the minor and the cofactor were and so on. All right, so here's your assignment. It looks long. Every other even. So we start with 8, we skip 10, we do 12, right? And most of these are all 2 by 2s. There is a, hey, try it in your graphing calculator to see how this works. I have a feeling you can figure out the math behind finding the determinant. You know how to put a matrix in, a 2 by 2 matrix in, right? So I'm sure you can figure the math out besides that. And then 49 is a very easy 3 by 3 determinant. 51, 53 are both 3 by 3s. 57 is an easy 4 by 4. 59, you'll have to do it twice. There's 2 of them that there's only 2 zeros, okay? And 73 is, hey, what happens when we try different operations? Is it commutative? Is it associative? That type of stuff, okay? Yes, sir. Okay, give me 1 second. Let me stop recording so it doesn't seem like it's such